Good afternoon to all our drone enthusiasts joining us for today's DroneTech Talk on underwater drones. My name is Silindi Lepepi Zungu, an associate for the Business Development Unit at the Saldanha Bay Industrial Development Zone. Before we go any further, I'd like to start with a little bit of background. So the DroneTech Innovation Showcase is a first event in a series of events brought to you by the Saldanha Bay Innovation Campus, an initiative of the Saldanha Bay Industrial Development Zone. These events include these DroneTech Talks, like the one you're attending today, an entrepreneur bootcamp, and a game of drones pitching event, all leading up to our very first Innovation Day. So please follow the Saldanha Bay Industrial Development Zone on LinkedIn for more information, or drop your details in the chat and our team will be sure to add you to the mailing list. Before we go any further, I'd like to go through a few housekeeping points from our end just to ensure we have a smooth session. So your mics will be muted for the duration of the session, as you have noted. Please send your questions through to the question and answer box when the question and answer segment of the session begins, or raise your hand to ask your questions to the speaker directly. The host will alternate between raised hands as well as the question and answer box. This will make for more interactive engagement. Before I take up any more of your time, I'd like to hand you over now to the capable hands of our industry expert, Mr. Grant du Toit, who is also the founder of Tech, for his talk on underwater drones. Hi, Grant, and welcome.
Hi, thank you. I feel very welcome. Yes, so my name is Grant du Toit. I am the founder of Tech. We're currently in the process of developing in-water drones. Ours is actually designed for both in and out of water operations. Our main target area that we're particularly focusing on in terms of sectors is the maritime, oil and gas, renewable energy, port and maritime sectors. My background in particular has been around in-water drones, or as we commonly call them, remotely operated vehicles. And I've been operating these for the past 15 years in the different sectors that I've mentioned earlier that we're focusing on as a business as well. So yeah, without fail, what I'd like to do is just give you a little bit of a history in terms of the whole lot and a bit of a definition. So one of the first things that anyone thinks of when you speak to them about a drone is something that has one or more sets of blades and flies. So like a quadcopter or a little helicopter or some sort like that. By loose definition, it actually opens up the whole thing in terms of what is a drone. And this is where the in-water component starts becoming a possibility. So one of the most common forms of in-water drone or underwater drones is what we call a remotely operated vehicle. And these have been in use for quite some time. Some of the first aerial drones that were used, driven by the defense sector. Like most things in terms of big industry, a lot of it is actually driven by defense sectors throughout the world. So the first unmanned aerial vehicle was recorded back in 1930, used in war times. So if you include further other devices in terms of underwater vehicles, then you start looking at a whole broad array. There's a big classification system under which these things fall under. They cover ROVs, AUVs, plows, trenches, and a myriad of different things. Ours that we focus on, as you can see behind me, is a magnetic crawler. And this, again, is a little bit more specific to meeting a particular demand or an application as such. So these underwater drones have been in use, as I said, for quite some time, myself using them for about 15 years now. And they have a lot of different applications. In terms of geography, the applications aren't really much different. if you say South Africa versus, say, the EU or the US or any other sectors or regions, one of the main differences that has just been, if you look at South Africa versus kind of the rest of the world, is how it's been adopted. So I've already mentioned the fact that the defense sector is a big driver behind this for whatever uses that they may see fit. And if you go into the private sector, there's a few sectors that have really driven the development of these devices. So oil and gas has probably been one of the bigger ones, at least for me in particular. In my experience, it certainly has been. And they've use these things in anything from just a basic visual application. In other words, let's do a inspection of a structure, then just using simple technologies like cameras, ranging right through to going with rather complex sensors, which can provide a visual component as well. In this case, you're referring to stuff like ultrasonic thicknessing to be able to determine the plate thickness of a hull or some kind of structural application. So that's the oil and gas sector. Maritime is very much also using this kind of thing. I focus a lot on what we call UWELs, or underwater inspections in lieu of dry docking. For those of you maybe not familiar with it, these are basically intermittent inspections that are required by classification societies. And these societies have periods during which these vessels or structures need to be inspected. And depending on what is needed, well, you'll have different solutions that will go out there, different kind of drone solution as such. The other applications that they'd be used for is in-water inspections. And these are normally just kind of spot inspections, which could be anything from maybe someone ran aground and they think they need to just have a look, or not think, normally they have to have a look and just verify what the condition of the structure is. In-water surveys is another one, and this particularly pertains to the sale of a vessel. Often they will ask for an in-water survey. Now, one of the main reasons that you would do these three types of surveys that I just mentioned right now is primarily because of the cost of dry docking. So if you are going to take a vessel out of water, obviously you're taking that vessel out of service. And there is obviously a large cost component to it. Dry docks, at least in South Africa, range from, if you cheap and don't have a big vessel, around 10,000 Rand per day, upward of 100,000 Rand. And then you're not including all the third-party people that you need to bring in for scaffolding and everything. So it takes quite a bit of time, quite a bit of planning, quite a bit of scheduling, because there are only limited amounts of dry dock facilities or synchro lifts or any means to basically get a vessel out of the water in order to do these activities. So if you can do work in water, you certainly have the potential to save yourself time and save money. And this is amongst the different applications that can be done. Two other areas in particular that are becoming on the rise at the moment, depending on where you are in the world, but it focuses around vessel and port security. So with vessel and port security, your big concern here is anything ranging from a kind of a militant component. In other words, there have been reported incidences where limpet mines have been adhered to vessels, and these can be triggered remotely or under certain circumstances. So depending on where you are in the world we're going to, sometimes they want to inspect the hull to make sure that there is no issues around that. Contraband is another big component. A large amount of smuggling that is done, whether it is just illicit products like cigarettes, for example, that have been brought in, right through to drug smuggling, which is obviously a big component in certain parts of the world. And these guys, they're constantly getting cleverer and cleverer as to where they hide these things and how they're getting them in, even using their own submarines nowadays. So these are just some of the visual and sensor-based type applications that can be used or are used pretty much anywhere in the world, really. Intervention is becoming more and more a big purpose for these different kinds of drones. So one of the main things that drive intervention with regards to drones is a big component that focuses around risk removal. So normally what first type of thing we do when we work with risk is we would like to try and remove it completely if possible. Now, obviously, this isn't always viable, because if you remove a risk entirely, your most common way of removing it in this case would be to say to remove a diver. But obviously, you need to do the work. You need to still be able to achieve the task. So the next thing that we would normally do is, how can we make the environment safe for a diver to be able to go in and do that work? So we'll set weather parameters and a series of different conditions, which would include depth, as to whether they can or can't operate. You might say that they can only do daytime operations or nighttime operations. So you can see how this also imposes further restrictions in terms of timelines to be able to get a task done or an application done, an intervention done. And this is obviously now costing money, because there's downtime, standby costs, and all sorts of other things. So the next step is to use an alternative means. So what you want to be able to do now is to bring in another device that can hopefully execute the task. And this is where, in this case, drones becomes a big component around what can and can't be done in terms of an application that's needed. So in my experience, the applications that we've done quite a lot of with, whether it's, for example, with a drone like ours behind me, or with ROVs for other companies that I assist, they are, for example, like overboard discharge isolations. So if a company needs to have a look at a valve or a spool piece that is on the inboard side of a vessel, they would need to blank off the outside. So obviously to prevent water from flowing in when they remove the spool or the valve. So this is the kind of thing that could be done. Fracture blanking. So there was recently an incident of a vessel that ran aground. Fortunately, it was able to come free on its own steam, but they had managed to get a fracture in the hull, and this was obviously letting in a fairly large amount of water, and a little bit more than what bilge pumps were designed to be able to handle. So they had two options. The one was to ship out a team of divers who would then basically try and remedy the solution, or the other one, which was to send out a drone and basically blank off. So in this case, they went with the drone. The main reason they went with the drone was because it was simply quicker to be able to get there, and it was also cheaper to be able to carry out. Less equipment, less staff, less people required. So fracture blanking, or any kind of blanking, sea chest blanking and stuff like that, is another application. Cofferdam installations and removals. So I've been a part of teams where we had to remove sides or parts of the side shell on a hull, which is quite a tricky thing, because obviously it's, well, in this case, most of the fractures were underwater, and if you're going to cut into the hull, then you're going to potentially flood the vessel, sink it. So the company that I was working with at the time came up with a very innovative solution whereby they had cofferdams that were lowered in place and assisted, in this case, with an ROV, and then the side shell was able to actually be cut out and new pieces securely put in place. And then later on, after testing, they could remove the cofferdams. Other things that's coming up more and more so nowadays is focusing around hull cleaning. So hull cleaning is becoming a very big thing. The big drive behind it is around food security and also around cost for operator. So invasive species is becoming a very big problem, whether you're in the sea or on land. It's becoming a more and more so an issue. And organizations such as the International Maritime Organization have started setting us out guidelines along with companies like BIMCO and Glowfiling to basically try and reduce and preferably even stop the transferal of invasive species into areas that have a risk of being damaged because of no competitor for these organisms that would settle. So they become quite rife. I've worked on a couple of jobs myself where we've seen this taking place on vessels, and it adds a substantial amount of weight onto the vessels. In this case, the vessel I'm referring to was an FPSO that was stationary. So lots of easy times for these species to settle. Creates a lot of problems, even in terms of structural integrity. When you clean it off, they often take the coating off the vessel, and this becomes a big issue as well. So hull cleaning, especially with the focus of being able to retrieve the biomass that you will clean off, filter it out, and return a clean water back into the port, is becoming a very big component around that. And then the efficiency side is another thing. So something that we've been focusing on is creating tooling sets that will be going onto our drones. And basically what we do is we clean the hull, we extract, and we pass off the benefit, not so much that we do, but the operator is passed off the benefit of a clean hull. And this makes it more streamlined. And that means that you will be burning less fuel to sustain a certain amount of speed. So one of the main things, especially for in the maritime sectors with regards to your cargo vessels and other oil tankers and the like, they would like to try and get from one place to another place on a constant speed as far as possible. That helps them to maintain schedules and other things like that. So they want to be able to do this. They need to be able to do it. It helps them which is a very common figure. Roughly on a saving for a trip, you could save quite a bit of money for yourself or whoever the operator would be. So one of the other things that's also really come into play around drones, especially underwater drones in particular, is to do with sensors. So aerial drones have had a lot of advantage in the past. The environment in which they operate typically has a very good line of sight. So most sensors, or many sensors, literally use a line of sight visual. So if you think of an aerial drone, it uses cameras, and it will use different sensors such as DVLs, or maybe not DVLs, but laser, for example. And these are all visual-based sensors, and they rely on a line of sight. When you bring those sensors into water, you have a different viscosity. So the water is a lot more dense, and any particulate that goes in tends to linger. It doesn't just fall down like sand or dust would fall out of the air. So it's made a lot of challenges around sensor use with regards to in-water or underwater drones. Slowly but surely, this has started changing, and over the years, we've managed to see a lot of benefits. around these sensor developments, especially with regards to size. If I think back about a Doppler velocity logger, for example, 15 years ago, you would be looking at something that weighed 30 kilograms or so. It was fairly large. And right now, they're coming out in a reasonably small, very compact size, and that even comes with AI capability built into it, along with the various other sensors that before you had to add in individually. So these things are all coming along. Acoustic sensors, so your little sonars, have also become more compact, which has allowed that to be put onto different devices as well. Photogrammetry is something that's come along in great strides, whether it's mono-based systems or stereo cameras. The ability to do stuff with all of these is quite phenomenal. The ability to scale, to measure, to build mesh images out of these things has certainly come a long way because of the sensors that are starting to enable us. Laser is another one. So LiDAR in particular isn't so much one that we use underwater for various reasons, but there are other forms of laser scanning that can be used under certain conditions. So I think those are just some of the sensors that that have really come into play and started bringing the industry and what we can do certainly into a much better space, and gives us the ability to service people better. So before I conclude, just very briefly, future of drones. Well, the great thing is, because of all these sensors and things I've mentioned before, it's allowing us to start coming into the similar place and use that aerial drones have been able to do. And there's a lot of new technologies that have been enabled through this and additional things. So I think it's going to be a good place to be in for the foreseeable future. And I think it could have a great amount of applications still further to come. Yeah, thank you very much again. Before I overstep my time, much more, hand it back over to you.
Thank you so much, Grant. That was such an informative session. We don't have a lot of questions in the question and answer box, so we'd like to encourage the attendees just to share their questions, or else they could raise their hand and we will take your questions as and when they come. But that also might mean that your presentation was so detailed and you left no stone unturned. So that's a good thing. Maybe just to address the one question that we do have from Anonymous, Anonymous is asking, how is underwater drone adoption in South Africa? It's a two-part question. And then he goes on to say, also as Symbitech, do you focus mostly on local markets or outside of South Africa?
Okay, underwater drone adoption in South Africa. South Africa has been one of the countries that has been a little bit slow on the uptake of these types of drones. That said, there are companies that actually do operate various underwater drones in South Africa. Most of them are obviously around the Cape Town area. It certainly seems to be one of the main hubs, but you will find them along the coast in most significant ports. It certainly could be done a little bit faster in terms of the adoption. There is a little bit of call it a mindset of, we've always done it like this, and the always done it like this has been focused around the use of divers. So that's pretty much been how it works in that regard. Slowly but surely, I think the technological component will break through more. At this stage, Symbitech, I wouldn't really say that we have a particular focus as such. We've had a lot of interest in South Africa for working with us. We've also had interest abroad. The foreign component certainly does seem to be more promising because, as I mentioned earlier, the uptake abroad is definitely more so than in South Africa, but the benefits to both regions would be pretty much the same.
Awesome. Okay, so it seems you've got quite a few questions that have recently come in. The first one from Alexander Kale, and he asks, what are some of the biggest barriers to underwater drone technology?
Sensors is probably one of the big barriers. They are very costly because most of them are made abroad. So it's obviously you've got forex costs, you've got shipping costs, you've got duties and the like, which has definitely made it a little slower on the uptake in that component. I just want to see if I can get back to that question. It seems to have gone off the screen here.
Is this?
You've moved it to answer. No.
Okay. Cool. Then there's another question from Wayne, and this is, do we have some guidance for people wanting to start a career in drones, and what sort of qualifications are required? Definitely happy for you to touch on that, Grant, but maybe just to give a little bit of insight to Wayne, we will be covering that topic specifically on the session we're hosting this Thursday. So same time, and I believe you should have the link and the information for that. So go ahead, Grant, please, can you?
All right, yeah, when, look, it's a very diverse area. I mean, we work with design engineers, electronical engineers, software developers. There is many different facets. So if it's something that you would like to get involved in, my suggestion is find out what part of it you are most interested in, and start from there. The other option that you have would be to reach out to a company such as us or one of the other operators and see if they have any posts available, or maybe even just do some voluntary time. See where you feel you could fit in and go for it from there. It's probably one of the best ways. The Innovation Campus is something I believe coming up now with options that will give you more details as well. So I'd stick around and follow that.
Okay. Okay, thank you for that, Grant. The next question, again from Anonymous. He asks, do you have any advice for anyone wanting to start a business in drones and or a business in manufacturing technology? I'm just going to go ahead and just respond to this, Grant, but happy for you to also add. So we do have a session scheduled for the 9th of September, the Entrepreneur Bootcamp. Details will be shared on the Saldanha Bay Industrial Development Zone LinkedIn page. So should you be interested in attending that, that would be a great way to get the answers you require. But Grant, please do assist Anonymous on his question as well.
Okay, so wanting to start a business in drones. Sure. It's been a long walk for us to get to where we've been going. We started off our first conceptuals in 2017. So yeah, it's not an easy route. I think you've got a couple of different options. I mean, you can go the route of building something specific to what you would like to do, which is what we did. So we believe that our solution has certain advantages over a free-flying device. Other people will simply rather just go and buy a free-flying device and provide a service. So those are definitely two things that you want to keep in mind, because it's certainly different routes to market. The one will take longer, but the other one has other advantages. So I think if you have anything that you want to get more specific into, I'll drop my email later on, and you're welcome to get more involved in the nitty-gritty. I think this is something that can take quite a bit of time to discuss, but I'm open to discussing it.
Thank you so much for that, Grant. Next question from Munib Badaroon. Are there any licensing and authorizations involved in underwater droning?
I'm assuming that this is the licensing comparative versus, say, an aerial drone. So with aerial drones, you have to have a license to operate them commercially. Within water, no, there is no real requirements. There's no real air traffic control or anything like that. you're just going to be operating within a small defined area. So there's no real licensing. However, for example, what we do is we lease or license out our devices, or it's what we will be doing. But I guess these are two different forms of leasing or licensing. So again, if you have any questions around those, feel free to drop me an email letter.
Perhaps Munib could also be unmuted should he want to maybe elaborate on his question a little bit further. But in the interim, I'll just go to the next question from Gerard Kloot. And he asked, does underwater drones also require an aviation? Okay, so you just essentially answered that question. And where would your company fit in? I'm not sure if you want to touch on that.
Well, if it's aerial drone versus underwater drone, then look, there is no real they're treated very differently from each other. I would say in terms of where we fit in terms of drones in the underwater space, the closest kind of equivalent would be what we refer to as ROVs, or remotely operated vehicles. We are able to do a lot of similar kind of stuff to what an ROV does. It's just that we've managed to develop a system that has a number of advantages over a lot of ROVs based on the area. In other words, the area in the water column that we work in, it's inherently unstable. So we found a way of stabilizing things.
Okay, so the next question comes from an anonymous. Do you have cost comparative case studies showing advantages of using drones, IPO divers, and intermediate class surveys?
No, not personally. I'm sure you could probably find them online. What I can tell you, for example, is I did a UWild a while back. In the case of this particular instance, divers we used on one occasion, and the project took just shy of, well, just a little over a year. We went in and provided the same service using remotely operated vehicles. It took us 5 weeks. So if you work out the day rate that is charged and all the equipment that is needed, diver versus ROV, 5 weeks versus a little over a year, I'm sure that would be quite obvious that there'd be a cost benefit.
Yeah, okay. Thanks again for that, Grant. So Anonymous asks, what is the power source of underwater drones?
Right. Typically, they use what we call a tether to link the drone or the robot to the top side. So yeah, the tether cable via a power supply on the top end. But there is a very big growth coming up in completely autonomous devices that are going under, and they're what we call residential devices. So they actually reside and live. They'll be installed close by to where they will work, and they are mission based. So they will be given a specific task to go and do. They will go and do the task, and they will come back home as such. Like aerial drone has a home or a point of origin where it starts. And inside this area, there will be a built-in charger, which will allow the batteries to be charged. So it's depending on exactly what kind of device you're looking at using as to where your power source would be coming from.
Awesome. I think you touched a little bit on this, but the next question again from Anonymous is, how can underwater drones help with marine conservation?
They certainly can help a lot. So in the case of something well worth having a look at, have a look for Google Blue Robotics. It's a American actually a university that started this off as a open source project. It still is open source. You can either buy the stuff from them directly, or you can take whatever they provide you and make it. But one of the particularly great things with this company is they've made everything to be very modular, and a lot of people have taken it and adapted it for a lot of nature and marine-based projects, which has certainly been very useful. I know one of the projects they set up is they had there's been a big like infestation of I think they're called lionfish and they're particularly difficult to handle. They're very poisonous. So they used these little in-water drones, or underwater drones, to basically go and capture them and retrieve them. I don't know how successful the project was, but my understanding was that they had managed to capture quite a few of these. So yes, that's just one example out of many.
That's really, really wonderful to hear. Next question from Graham Walker. He asks, how does the market look for global commercial and military underwater vehicle suppliers in terms of opportunities in Africa?
Sure. The African component is quite difficult. We've really struggled ourselves to find market access in the African market. Very similar to South Africa is that the uptake has just been very slow. People are not familiar with the technology, and they go rather with an option that they understand best, which is often, as I said before, it focuses around divers. So I certainly believe there would be a lot of uptake. I mean, the benefits that Europe and the US and the UK and Scandinavia and all these other areas that have adopted these so well would apply to anywhere else. So I think if you can get inroads into these areas, I mean, we've started making some now on East Africa, and this definitely would open it up. There's a big drive with companies like organizations like the International Maritime Organization that is motivating having similar standards, because, for example, vessels have to go from Africa into Europe. And if our regulations and standards are different, then it makes trade difficult. So they're trying to work with their partners in different parts of the world. And in this case, it includes Africa. So there are drivers behind it.
Thank you so much, Grant. So in preparation for today's session, I did a little bit of reading up myself, and I was very interested to find out that this kind of technology has been in existence since the 1950s, and I think you mentioned 1930s. So there's obviously been a lot of advancement in the technology. So this is leading up to the next question by Anonymous, who's asking, where do you see underwater drone tech in the next 5 to 10 years?
Again, this is going to be field specific or application specific, but one of the main things, as I've mentioned earlier, is sensors. And in our case, we've played a lot with machine learning, machine vision, stereo visuals, and photogrammetry. So when you start putting all of these different pieces of technology and software and all sorts together, then you can start doing a lot. Something that I didn't mention, but with AUVs in particular, swarm technology has become quite a lot. And with aerial drones, swarm technology is also becoming quite large. So in the arena of hull cleaning, for example, you're getting tankers that are coming in. They're almost 400 meters long in some of the bigger cases. And to clean a surface like that, if you work out what the surface area is, it actually takes quite a while. These activities are being done normally when the vessel is in port. So you have the amount of time to clean that vessel or work on that vessel between when it is tied up and when it casts off again. So sometimes a singular device might not be your solution, or alternatively, the vessel sails off with an incomplete job. So you can start using swarm technology as well. So there's a lot. As I said, it is industry specific, and it's going to focus around what exactly you want to be doing. But 5 to 10 years from now, I would love to see multiple drones of ours being put onto a vessel at one time, each entirely autonomous, specific tooling, specific activity, going in and getting it done quick as possible.
Okay, thank you again, Grant. Manib has a follow-up question. He asks, are there any companies, or are there many companies like yours coming up in South Africa?
No, they are not. There are certainly a couple of ROV companies in South Africa, All of them have pretty much bought their own equipment. In other words, they've sourced it from abroad, and they are either leasing it out or they will provide the service for you depending on what the activity is that would need to be done. In terms of what we're actually doing, my knowledge is we are the only operator in South Africa.
Okay. The next question is asking, does South Africa have any competitive advantage for drone manufacturing?
You know what? I'm going to actually say I really do believe that there is. You know, in the past, everyone has been, you need to ship out your manufacturing. And with exception to software development, everything else I have managed to do cheaper in South Africa than abroad. Obviously, at this stage, we're small scale in terms of the volume. So maybe things will change for us a little bit later when we start producing much larger volumes of these devices. But there's a lot of things that you need to consider, like quality, for example, of the build. There are certain parts of the world that are very well known for high quality builds and others not so much so. And this is, I guess, a bit of a compromise that you make in terms of the quality of your build that you do. So we've diversified in terms of where we source our materials. But in the end of the day, I mean, like the device you see behind me, this was almost all sourced in South Africa in terms of raw materials. It was all machined, milled, fabricated in South Africa. The only outside components has been on the development side of it.
Interesting. Oh, wow. Okay. Last question from Anib. Is your design in-house or is it mostly in-house?
Yeah, the design is all entirely in-house. Everything in it is in-house. A lot of the types of components and stuff which we use are still coming off the shelf, or we take them off the shelf and we modify them according to what we need.
Okay, and the last question comes from Graham Walker, who asks, with some similarities regarding aerial drones, how is water space management applied, and how do you alert other potential underwater vehicles users, and do they have their own obstacle avoidance or other ROVs?
Yeah, normally what we would do is, if you're going to be working with multiple devices in one space, you normally set your goal or your project up with everyone being on the same team. It's very rare that you will have multiple companies doing simultaneous operations. And even when you do, you normally are required to work together. There are procedures and standards that are required. In terms of obstacle avoidance, yes, there certainly is. Most of it is acoustic based. So you're looking at sonars, or which we call them pingers as well, that you'd be able to use to detect. But probably one of your main things is just making sure that you define your scope of work very clearly amongst everybody, and it's not randomly people just moving around. I think something that will happen in the future is, as more and more operators come along and we're all hypothetically working at Key 5 at Cape Town Harbour, or later on at the Saldanha Bay New Port, you may have different operators each working on a separate activity, which would not really require them to kind of work together. And then I'd imagine you'd almost need to start adopting a kind of an air traffic control type of thing. Excuse me, just to make sure you don't get entangled. Otherwise, it could become messy.
Okay. As I said, that was the last set of questions. Thank you once again, Grant. That was an incredibly informative and enlightening session. I think we all all are so much wiser now and know so much more about underwater drones because of it. I think you have shared your details in the chat box. So if anyone is maybe looking to get in touch with you, has any more questions, they're able to do so. Maybe just to check with regards to your presentation, will you be sharing that at all?
Well, I don't really have a presentation. I just got the notes, but I'm happy to share those to you guys, and then you can pass them out.
Okay.
I haven't actually made my details available in terms of email address and website.
Okay.
Maybe see if I can
You want to
put it out
in the chat box.
I'm not actually able to add a chat in.
I think what we will do is just share that information on our Innovation Campus LinkedIn page, and that way everyone will know how to get a hold of you. Thank you so much again, Grant.
No
do
worries.
appreciate your time, and thank you for everyone in attendance and for your participation in the session. We definitely look forward to you joining us for tomorrow's session on integrated 4IR technologies into school. And again, we've really benefited from this informative session, and we're really excited to learn more, and I hope you have a good day further. Thank you, everyone.